Hey Algebra 2, here's lesson 5.2 about solving quadratic equations by graphing. So when or how do we go from a quadratic function to a quadratic equation? Well, when we're in function mode, we have f of x is equal to ax squared plus bx plus c. To go to a equation, all we're going to do is replace our f of x with 0. So instead of f of x, we have 0 equals ax squared plus bx plus c. And this seems really minor, but it allows us to do a lot more with this equation. So what are the zeros of a quadratic equation? Well, those are where the equation equals 0 in the y, thus those are the x-intercepts. So the zeros of a quadratic equation are just the x-intercepts. That's all it is. So vocab word for you. Zeros and x-intercepts. Same thing. What are the roots or a solution of a quadratic equation? Hey, same thing. They are still just the x-intercepts. So the big idea here is that I have 4 vocab words. I have zeros, I have roots, I have solutions, I have x-intercepts. They all mean the same thing. So all mean the same thing. And I'm going to be using these interchangeably from now on, so we have to get used to using all of them. Alright, true or false, a quadratic equation can have 0, 1, or 2 real solutions. Well, what does it mean to have 0, 1, or 2 real solutions? To have 0 solutions means whatever your parabola is, it just never crosses that x-axis. So can we have a parabola that touches the x-axis and has no solutions? Yeah. So we can have 0. Can we have a parabola that goes up, touches the x-axis, comes back down, and just has the one solution? What about 2 solutions? Well, can we have a parabola that starts high, low, and comes back, but still intersects the x-axis 2 points? Absolutely. Can we have 0, 0, 1 real solution? Yes, we can. Statement true. So let's use that information to solve by graphing. Now, to be able to graph, we know how to graph, so hopefully you watched one video or you were in class for that. You know the first step, find the y-intercept, which is always just a constant function. In this case, it's 8. So I'm going to pop up to... Alright, next thing we need to do is find that axis of symmetry using our negative over 2a form. In this case, it's going to be -6 over 2 times just 2. 3. This one, lines kind of fade out really weird here. I'm going to actually make my symmetry with some lines. That's what I'm doing. Once I've found axis of symmetry, I'm going to use the x found there, plug it in my equation, and find my y. When I do that, I get -1. Right, cool. My vertex -1. Just because I want to know what happens going on here at negative. I'm gonna make table just to see. Let's go on. So negative. Oh, sorry. This is supposed to be an x. Just ignore whatever I did there about that. When I put in 2x, I'm sorry. That's when we find out what my y is gonna be. When I plug -2 here, I get 4 minus 12 plus 8. That actually ends up 0. So -0. When's it -1? 1 minus 6 is -5 plus 8, which is 3. -1 over 3. And then because I've done that, I'm not going any further because I know that my axis of symmetry just shoots these over. Now I'm going to slide this way, just can sketch this a little accurately. These are kind of hard, so practice makes perfect. Alright, and of course it keeps going on. Alright, so are the zeros, or or solutions or intercepts. So what values of x true? Well, it goes through negative and at negative 2. In this case, we have a graph that has a real solution. Let's hop over the back. Same thing here. We're going to spy graphing. I would suggest pausing and coming back once you've tried their own. Alright, so this one, I hope you've paused the video and tried it on your own. If you haven't, do it. So I know the first thing about this, that it's not in a form that I can't graph it in the form then. So what I'm going to do is I'm going to arrange these terms. They're all on one side and equals 0, like I saw on my last page. I'm going to do moving the x squared over 8x, and I will end up getting squared, because this becomes 5, minus 8x plus 16 equals 0. This is a form I'm more familiar with. This is what I'm more, and it allows me to do actual stuff for graphing. So in the y-intercept, it's 16. Now, while this is technically correct, it's kind of hard to graph on here, so I'll go through the steps of the rest, and we'll use that information. So let's find the axis similar to we're used to. We're going to use that formula x equals negative over 2a. In this case, my b is negative 8, so negative 8 over 2 times 1. I get 8 over 2 is 4. When I add that in from vertex, I get 4, comma, plug it back in, obviously, so I get 16 minus 32. And you're going to end up 0. So my vertex is at 4, 0. So symmetry is at 4. And because my y-intercept is somewhere way up here at 16, and I know there's a positive quadratic, I know it's going to open upwards, so I'm just going to do one of these. It's going to be a sketch. You'll get the idea. So what is my solution here? Well, since it only touches the x-axis once, the only solution is that exact number. So when x is 4, that is the solution. Alright, find two real numbers with a sum of 6 and a product of 10 or show that no such numbers exist. So this one didn't even give us equations. We have to start out with equations. So a sum of 6. X plus y must equal 6, and a product of 10, x times y equals 10. And we need to use this information to either find these numbers or show that they don't work. So once I have these two equations, you might be saying, these aren't quadratics, I don't know how to use these. Well, let's use a little bit of our substitution elimination knowledge from the last chapter. Let's start by solving this one for y. If I do that, I'm going to get y equals 6 minus x. I can then use that and substitute it in for y in my second equation, and say x times 6 minus x equals 10. Why did I solve for y instead of x here? If you notice the other equation up here, there's no y's here, so I have no use for y when I'm solving these by graphing. So I want to try and get rid of it if I can. Alright, when I multiply this and rearrange it so it looks all nice and pretty, I get negative x squared plus 6x, and then I'm going to pull that 10, I'm going to leave that 10 over there, and I'm going to move this stuff to that side. So I end up getting 0 equals x squared minus 6x plus 10. Same thing I always do. Once I have this beautiful equation, I'm just going to find my y-intercept. It's at 10. Find my axis of symmetry. It is at 6 over 2, which is at 3. Find my vertex, which is at 3 something, whatever 3 something happens to be. 3 it looks like? Yeah. Alright. So let's put that information on there. Y-intercept is way up here. Can't really put it on there all that well. My axis of symmetry is at +3, so I put that on there. Vertex is at 3, 3. I know it's positive, so it's going to shoot up like this. Alright, so what are my two real numbers that work for x? Well, where does my graph intersect the x-axis? It doesn't. Since it never touches this line, there are no solutions. So our final answer is no such numbers exist that would give us two real solutions. Alright, last one, word problem. You can read through this. Basically, at the very end of the problem, it says, hey, he did this thing. So it gives us the formula h of t equals -16t squared plus h 0. The nice we don't have to list as h of 0. You'll notice over here in our picture it says that his starting out was 35,000 feet. So I rewrite this as h equals -16t squared plus where he started with 35,000. Notice there's no term. This is actually a good thing for us. In order to solve this, if we read it as an equation at 0 instead of the at, we can solve it moving the order over. So I'm going to move the 16t over, just add it over and say 16t squared equals 35,000. Divide both sides by 16, you get t squared equal 2,150.25. Sorry, I didn't realize. And then to finish it up, how do we undo error? Just take the square root of both sides, and we end up t equals technically plus or minus. We took the square root, but since we can't have that negative world problem like this, final answer is just t equals approximately 46.44 seconds. All right, that's all there for 5.2. Go do your homework. We have any questions.